Welcome to solverfy.
We are asked to apply a previous exercise to a model of friend groups. So we're told that we have a group of people, and we're asked to show that in this group there must be two people who are friends with the same number of other people in this group. So recall from a previous problem, exercise 18, that if G is some graph with vertex set V and edge set E, if G is a simple graph, and if has at least two vertices, so that the cardinality of V is greater than or equal to 2, then it follows that there exist two vertices, U and V, which are distinct, such that the degree of U is the same as the degree of V. So, if we're trying to model friends, we're going to take, so this is the friends graph, which I'll call equal to G, which is the pair VE. We'll want to take the vertices to be the people in the group, and the edges are going to be the set of all pairs of people from the group such that U is friends with V, and in order to use the previous theorem, we need to establish that it satisfies the criteria. So first, is our graph going to be a simple graph? Well, what do we know about this graph? We have, first of all, the edges are going to be undirected, and this is because friendship is a symmetric relationship. So if you're friends with somebody, they have to be friends with you. This is more than just knowing somebody. And also, if we ask about are multiple edges allowed, we have that multiple edges are not allowed, and the reason why is there's really only two conditions. Either a person is friends with another person, or not. They're not friends with that other person. I think this might be a little bit of an oversimplification, but for the purposes of this problem, we're going to make this assumption so that we can apply this theorem. And now the next step is we want to check to see if loops are allowed. So, sort of a weird question, but I'm going to say no loops are allowed in this case. And to justify this, it's hard to believe that anybody is not their friend. So I'm going to say that everyone is their own friend. They're friends with themselves. And so adding loops makes the graph needlessly complex. I suppose one could also argue that there's no loops because friendship is a relationship that requires two distinct persons. But I think my explanation is also decent. So what this establishes, since the edges are undirected, multiple edges are not allowed, and loops are not allowed, it follows that the graph G is a simple graph. And notice that since V is the group of people, and people is plural, it follows that the cardinality of V is going to be greater than or equal to 2. So a group has to contain more than one object. And therefore, by the theorem, there is, or I would say there are two people. U and V such that the degree of U equals the degree of V, and therefore it follows, since the degree of a vertex is the number of edges which the vertex lies on, follows that the degree of the vertex is the number of people that person V is friends with degree of U equals degree of V. This tells us that person U and person V have the same number of friends in this group.